In our paper, we address the state space explosion of rank-based Büchi automata complementation. The explosion is caused by two factors, mainly a high degree of non-determinism and the use of unnecessarily high bounds on the ranks. We propose several optimizations which are based on the concept of super tight runs, which are the only runs that need to be preserved in the complemented automaton. We reduce the complemented automata by reducing the maximum rank used and by reducing the non-deterministic choices that are taken. So we can, for example, remove some states like this. When compared with the state-of-the-art rank-based procedures, we obtained significantly better results, in some cases even exponentially smaller automata. We also compared with state-of-the-art tools for Büchi automata complementation, and in 22% of cases we obtained a strictly better result than any of the tools, and in 63% of the cases we obtained at least as good result as any other tool.
Hi, I'm Kibeli, and with my co-authors we designed a framework to test inclusion between Büchi automata. Our framework is simple. The central ingredients are well quasi-orders, and essentially they just need to verify two conditions, a monotonicity condition, and then a property with respect to the language we're checking inclusion into, that we call the preservation property with respect to that language. Our framework is general. It works for the omega regular into omega regular case, and it also works for the omega context-free into omega regular case. And finally, it is efficient. We have implemented it, and our tool bait works very well on many of the benchmarks on which we tested it. So if you like well quasi-orders and if you like Büchi automata, maybe you will also like this framework. And I hope to see you in my talk.
Hello. This is a brief overview of our paper on nominal Büchi automata with name allocation. So what we wanted to do in our paper is to get a handle on linear temporal properties of name allocation, like the property that some name is used infinitely often. And for this purpose, we introduce a new automata model called Büchi RNNA that uses a Büchi acceptance condition, is based on an infinite alphabet, and uses a theory of nominal sets that gives a nice, convenient way of talking about name binding and alpha equivalence and related concepts. And what we show as our main result is that the language inclusion problem for Büchi RNNA is decidable in doubly exponential time, which is quite a rare property among non-deterministic automata models over infinite alphabets. So we think that our model is a good compromise between expressivity and good algorithmic properties.